Okay, so in this video, we're gonna just talk a little bit more about the probability and some properties. So in the textbooks, they tell us there's a few types of probability, three, and the one we're following. The classical probability is the one we're more used to. It says if an experiment has n equally likely outcomes, and it's bold, equally likely is important, right? And if the number of ways an event E can occur is m, then we write it like the probability of the event E is m divided by n, right? So there's n is a denominator. We used that in the past. M is the number of outcomes, your favorable outcomes that you're looking for the event. So it's just m over n. The empirical probability is based on observations from an experiment. The empirical probability of an event is a relative frequency of the event. So you keep track of something happening, and you keep track of the results you get compared to the total numbers you have repeated the experiment. For example, instead of calculating the probabilities for my rolling a pair of dice, you can roll a pair of dice multiple times and find out how many times of those did you get a 7. Yeah, you would expect that if you roll it 7 times, if you roll it 6 times, one of them would be a 7 because the probability is 1/6. But it's not going to happen. So we'll talk about that in a minute. And the third one is a subjective probability, which is based on intuition or educated guesses and estimates. For example, when doctors tell you a patient has 90% chance of recovery within a week, they're basing that on their experience and their knowledge of the matter, right? But this is not really a probability like the other ones where you calculated something or you saw an experiment. So the law of large numbers is huge. This one says that as an experiment is repeated over and over, the empirical probability of an event approaches the theoretical probability or the classical probability of the event. Okay, that's why you can match them together. So my example here is if you flip a coin many times, and keep track of the proportion of tails. So this would mean that you roll it once, that's the denominator, and you didn't get tails. So 0 out of 1. Then you roll it again, and you got 0 out of 2. That means you get tails the second time either. Then you roll it the third time, and you got your first tail. So far, the ratio is 1 to 3, 1/3. You roll it again, and you didn't get tails, right? This could happen, and then you get 1/4, right? This means you did get tails, so the number increases. You did it 2 and 5 times, 3 and 6 times. I got tails again, and tails once again. Yeah. So I don't know what number is going to follow, but you know it could happen that the next one is or not a tails, right? It could be 5 out of 9. If I do it again, I might get 5 out of 10, or I might get a tails again, so 6 out of 10. So these numbers are going around 1/2, but if you do it many times, you expect the number to get close to the actual probability that we know is 1/2, right? So that's the law of large numbers. And if you see the experiment many times, you would expect to get close to the probability of that you actually would do if you calculate it another way. So some things you cannot calculate another way, but so you still say, well, this will trend towards the real probability, and have no other way to finding it, right? And we do that, for example, what's the probability that somebody driving the freeway at 100 miles per hour gets into an accident? Well, there is a probability there, and we track of how many cars we can track going at 100, how many fall in an accident or stuff like that. But there's no other way to count it. We just keep track of things. Okay, the basic probability things is that the probability of an event is always between 0 and 1. The probability could be 0. The probability of something could be 1. No probability could have an answer more than a 1. So that's a crucial thing to understand, and a big in my classes, it's a terrible thing in any question. If the question says find the probability of, and somebody in the answer says 3.2, well, at least if the student didn't even tell me, I know something's wrong because the answer cannot be 3.2, but this is what I get. Well, if it doesn't even bug the student that the answer was 3.2, I feel like there's a basic misunderstanding of what the probability is measuring, right? So If you get an answer like that and you don't know what's happening, at least tell me or tell your instructor the answer is wrong. I know, but I know it can't be more than one, but I'm keep getting 3.2. Okay, at least we know that you know something's wrong. You didn't have time to fix it. But that's totally different than submitting your answer, probability is 3.2, and leaving the exam happily. It's not okay. Well, that just means that the student has no clear concept of the probability yet. The another thing that is very useful is to know is that the complement of an event. So the complement of an event is something that happens whenever the other thing doesn't happen. So two events are complementary if they could not happen at the same time, and between both of them, they cover the entire sample space. So the probability of both of those added is 1, right? So sometimes it doesn't make sense right now a lot. We'll do a simple example, but later we'll do, in an application, we're finding the probability of the event could be very complicated. So it's a lot easier to find the probability of the complement of that event and then subtract it from 1. So this is going to be very useful later. Okay, this is some very simple examples. A pair of dice is rolled. Find the probability the sum is a 4. So I already did this in my past video. So let me bring that table again very quickly. I have a die between 1, 2, 3, 4, 5, 6. I have another die between 1, 2, 3, 4, 5, 6. I'm going to make a very quick grid here. You have to be careful that you're only counting the ones in the center, right? So the outside of you're counting from here. These are the ones at 36. Okay, and then the sum is a 4. I can get a 4 with. Did I do it wrong? Oh, I need one more line here. That's what was weird right there. Okay, so I can get a 4 in 3 ways, right? A 3 in the 1, the double 2, and the 1 in the 3. There's only 3 ways I can get a 4. So it's 3 divided by 36, or 1/12. You might be asked to use this into a decimal, but most instructors wouldn't care if you leave it as a fraction, although just be careful. Now, the second one asks, what is the probability that the sum is not 5? It's not hard to do that, but this is where I'm going to use the complement. It's a very simple one, but instead of finding that, I'm going to find 1 minus a probability that it is a 5, right? So this is, if I call this the event E, the probability of E is the same as 1 minus the probability of E complement. That's the way we wrote it in the last slide. So, and the probability that it's a 5, well, I can get a 5 in the next diagonal, right? 4 and 1, 3 and 2, 2 and 3, and 1 and 4. So there's 4 ways. So it's a 1 minus 4 over 36. So if you want to simplify that, that's 1/9, right? That's 1/9. 4 times 1 and 9 times 4. So it's 10 minus 1. Sorry, 9. I don't know how to do math. So it's 9 minus 1, 9. So it's 8/9. So there's 8/9 chance that you don't get a 5. You can also, this is like the empirical probability. So if you have, instead of now I have a table, the frequency distribution gives the ages for customers of an online store, the ages and how many customers are in that age. So if a customer is selected at random, what is the probability that the customer is less than 28 years old? So this is not by random, it's exactly right here. These are 28 and over. So less than 28, you include those two. So it's 36. The total is 60, so 60 over 36. If I divide that by 6 top and bottom, I get 6/10, so 0.6. That's easy to convert. And the second one says, if a customer is selected at random, what is the probability that the customer is not in the youngest group? So, of course, in this one, it's going to be, again, easier to do what's the probability that he is in the youngest group and subtract it from 1, right? So the youngest group is this one, so there's 12. So it's going to be 1 minus 12 over 60. Right? You could have also added the other ones, but I mean, it's just to make the point, it's easier to do 1 minus 12. So it's 16 minus 12 is 48. And if you divide by 6, you get 8/10, right? 6 times 8 and 6 times 10. So 0.8. Okay, so that's our intro to probability. We'll add those to the mix and make more videos.